So in this video, we will try to solve this problem on best time to buy and sell stock. It's a LeetCode easy problem. Now let's go to Google Docs and try to solve this. So I have pasted the problem here. So in this problem, we have been given an array of prices, right? And where each price I is the price of a given stock on that ith day, right? Then our goal is to return the maximized profit one can make via this list of prices he got. And by choosing this, and we can choose a single day to buy one stock, and then we have to choose a different day to sell the stock. And if we cannot make any positive profit, like there's only then we will not make any transaction, and basically our profit will remain as zero, and we can simply return zero. And the last thing is we cannot sell before buying. So we need to buy first, and then only we can make a sell, and we cannot also buy and sell on the same day. Okay, so that is the whole problem. Now we can see this first example. We have this list of prices on different days. So here, to get the maximized profit, we are saying like we would be buying on day 2, which is basically this one. On this day we are buying it at price 1, and then we are selling it at day 5, which is basically this one, and then this we are selling at price of 6. So in total we are making a profit of 5. That's why our output is 5. So this is the maximum profit by which we can get based on this list of prices. Okay, now going to the second example. In this we have list of these numbers. We have 7, 6, 4, 3, 1. So here we see the prices are keep on decreasing. So irrespective of any day we will buy, the next day the price is dropping from the day before. So we will never be able to make a profit via this data. So that's why our max profit here would be 0. So this is on that part. And on the constraint side, the maximum length of this price could be 10 to the power 5, and each price cannot be more than 10 to the power 4 and cannot be a negative value too. So yeah, now let's try to think solution and see how we can find optimum approach for solving this problem. So since for that, let's copy this example and then try to analyze and find out some way by which we can solve this problem. So I've copied my input list of prices. I can just mark the indexes of this. Now let's see what we can do here. We have to sell on the minimum. So basically, to make a maximum profit, we have to sell on the day where the price is minimum. We have to buy on the day where the price is minimum, and we have to sell on the day where the price is maximum. So in this way, we can make maximum profit. So one way I'm thinking is to take 2 variables. One is this minimum buy price. So I will be looping through this array, and I will be keep on updating this minimum buy price. Okay, and let's see. Let's just loop on this array and see if I can get something. So when I is 0, my minimum buy. Let's initialize this minimum buy price to infinity, right? Okay, and I'm saying this is my array, and I'm saying my minimum should be this. I'm simply getting the minimum of prices, so I can say prices. Just trying to find the minimum price. So I will be keep on iterating. So when the I is 0, my minimum price would be 7, because initially it was infinity. Okay, and I can take one more variable, which is to store the profit, to store the max profit. So I can say max profit, and I can initialize this max profit to 0. Okay, so my price, prices of I is less than the minimum of price, right? Minimum buy price. Then to simply update my minimum buy price to the new value. Okay, to the price value. But if my price is more than the minimum buy price, then why not think that this price is a price to sell? So, and then I can subtract my minimum buy price with the price that I'm hitting on, and this will give me the selling price. So I can say then make my max profit as max of whatever price it was previously, and whatever price I got by my current status. And my current status can be found out by my current price and the minimum price I have so far. I think with the help of this formula, we can derive the answer. Initially they are at infinity, and now the max profit is 0. Okay, now let's start iterating this list of prices. So when I am I of 0, then is my current price less than the minimum price? Yeah, because minimum price is infinity and current price is 7. So make my minimum price as 7 now. This will become 7. Now let's make I equals to 1. And now is my minimum price less than minimum price? No. Then still update my minimum price to the new value, which is 1 now. Now make I equals to I point to index of 2. This time the price is 5. Is my price of 5 less than the minimum price? No. Then this time I would be going to my else path and I would be updating my max profit. So my max profit will become price of 5, which is 5 minus my minimum price, which is 1, which would be 4. And 4 is definitely greater than the initial 0 price, right? So it will become 4. Okay. And similarly, I can do it for index. Here my price is 3 and minimum buy-in price is so far is 1 only. So again, I will subtract 3 from 1, which is 2, but it is not greater than my already max profit. So I will ignore that and move to the next number. So okay, so now I've done till 3. Now I will be doing for 4. For fourth index, my price is 6 and my minimum buying price is 1, right? So is current price smaller than the minimum buying price? No. If that's the case, then just update by max profit. So let's just subtract the current price, which is 6, with my minimum buying price, which is 1, and it gives us 5. So is 5 greater than my existing max profit? Yes, existing max profit is 4. So I will update it to 5. And then I will be moving my index to the last element, which is fifth index, and element price is 4 here. Is my price still greater than my minimum price? Yeah. Then I will again try to update max profit. But here, when I subtract 4 minus 1, it will stay, which is not greater than the max profit I have. So I will simply ignore that. So till the end, my max profit would be simply this max 5, and I will simply return this as my output. In case of example 2, you see, like they will be keep on decreasing, right? So in a way, I can say like always I will be keep on updating my minimum buying price, since each price is smaller than the previous price, right? So only this statement will keep on be updating throughout my all the iterations, and the max profit will remain as is. So till the last also the max profit will be 0 only. That's why for this iteration it will give us 0. So this approach seems to work for this example 2 also. So now let's try to write down the complexity of this approach. Okay, so our time complexity would be, since we are just iterating we are doing a single iteration throughout the loop, right? So the time complexity would be the length of this price array. So I can simply say my time complexity would be O of n, where my n is basically the length of the prices array. And now talking about the space complexity, here we are just using these 3 variables, like one to store the minimum buying price, and other is to store the max profit, and they will be indexed to one. So just using a single variable, so the space complexity would be just O of 1. Okay, so yeah, that is the complexity of our current approach. Yeah, so now let's try to code this problem with this approach. So I can type solution here, a function which will return me max profit, and this function will get list of prices as an input. Okay, and now let's just create our 2 variables. One is minimum buy price, and the second is our max profit. Minimum buy price, we will initialize it to infinity initially. In JavaScript, infinity is written like this, and our max profit would be 0. Okay, now let's just loop over our prices. So I'm just using that off syntax. I can select price of prices. So I'm one by one. This off syntax will basically give me one by one price out of this price array. And then inside this loop, I can check if my price is less than the minimum buy price, right? Then to simply update my minimum buy price to, we are using Google Docs, so this indexing, this indentation is a bit tricky, but we can practice coding on this, and then we will get used to the interview environment. Now, else our price is greater than or equal to the minimum buy price. It does not matter whether it is equal to or not. So anyway is fine. If they're not equal also, then also the profit would be 0. So if they're equal also, so then profit would be 0 anyhow. So no need to worry for equal to sign here. Here in the else, I can simply say update my max profit, and my max profit, get my max profit to, let's see, I'm using math of max, and let's first find out the profit. So profit would be the current price, which is greater than the minimum buy price that we know, greater than or equal to the minimum buy price. So I can subtract my price with this minimum buy price. My bad. And it should be greater than our max profit, then only it will update max profit, else it will remain our max profit as is. So we can have that thing here. So only if this difference is greater than our max profit, then only assign update the max profit, else keep our max profit as is. So this statement will do that, and at last I can simply return my max profit. Yeah, so that should be our code. Now let's just try to paste this code in LeetCode and see whether our code is correct or not. Paste this in the LeetCode. I can run this code. Let's see. Okay, let's see. Okay, so one problem is just return. Okay, there's a typo here. So that is a problem on coding on Google Docs. Like, you must be too much careful about the variable names and things. So something might break there, which we can only see when we are running it. Okay, so now let's see. Our compile time must be gone now. Cool. Both these tests are passing. Let's just try to submit our code and see whether it passes on all the tests or not. Voila, everything is passing, and our solution is beating 81 solutions, 81% of solutions. So yeah, that's nice. That is pretty much on solving this problem on best time to buy and sell stocks. Thank you.